Okay, so we know these double angle formulas, right? Cos 2x equals 1 minus 2 sine squared x. Cos 2x also equals 2 cosine squared x minus 1. So what you could do is you could do a little rearrangement. For example, I can move the 2 sine squared x to the left side and a cos 2x to the right side. Then divide by 2. And that's called a power reducing formula. Okay. You probably don't know. This is important because if you're given a trig function with an exponent, and somehow you don't know how to deal with it, or let's say you got higher to like the 6th power, the 8th power, whatever, you can actually use power reducing formula to get this down to a lower power. Just by manipulating the double angle formula, which we can derive from the sum or difference formulas.
How did that get us to the lower power? Go square.
No, it's not. The other side is some square.
But that was neither.
Yep, it was.
Neither.
No, that's what I'm saying. If you have sine squared x, you want to reduce the power. You replace with all this. Sine squared x equals all this. It's yet another formula.
How would that work?
Oh wait, this is just like
I'll get to an example about that.
That's just an identity.
Yes,
Is
right.
oh yeah.
Go, Grace. You have a question? No. Okay, well, we'll do an example in a moment. Okay, guys, let's keep going. Again, move things around. Cos 2x plus 1 equals 2 cos squared x. Divide by 2. And it's another formula we have. You can also do likewise with tangent squared x. Tan squared x. Would that be the same thing as saying sine x or cos x squared? You guys agree with that, right? Which also could be rewritten like this. And if you do a little manipulation, see how the 2's cancel? So you're stuck with just this. All's good? Okay. So those are other formulas. I'm not going to give these to you. You can drive them. So right here. So now, let's utilize it for something like number 4. So you want to rewrite this as a sum of first powers of cosines of multiple angles. So if you think about it, wouldn't sine 4x just equal this? Sorry. It's where the messy handwriting gets me in trouble sometimes. That's a superscript. My apologies. I think you leave your answer like this. Actually, I'm gonna take it back. I am gonna FOIL it. Because technically you don't have first power cosine. So far, okay with that? Right? Like FOIL. 1 and 1 is 1. then cos 2x, then cos 2x, then 2 cos 2x, then cos 2x, then cos 2x positive cos squared 2x. We're okay with that?
Okay, cool. So what you gotta do is take care of that bad boy. I know. Yeah, I would do that, wouldn't I? But you'll be okay. You'll be okay. I trust you guys can do this. Make a little space here. Don't worry. How are we gonna do it? You're gonna break apart the fraction. This is where you have to be incredibly fluid with your fractions. Okay, this is why people kind of stop after this course. Like if you're talking to anyone who took math 40, 50 years ago, trig was like the big thing in high school. Took trig, you're a big deal. And now you guys do trig like in ninth grade. Jeez. And remember this. Equal that. So if you simply get rid of this and put that right here, work it out.
Yeah, it's cosine squared US.
No, by substitute for cosine squared. Oh, my bad. My apologies. It's gonna be this, guys. Yeah. Yeah, my apologies. No, geez, I can't believe I did that. I was really that was a huge mental error. Here, learn more neatly. My apologies. Thank you for stopping my tracks.
Okay, what happens here? Those relations are the angles. That is double that angle. That is double that angle. That is double that angle. So when you reduce the power, cosine squared 2x, you're letting theta be 2x. So that's theta, that's 2 theta. So if I let theta be 2x, there's something cosine 2 theta. But plug it back into the mix. Theta equals 2x. We call it theta. That's 2 theta, but when you put that back in, you should get 4x. That's reasonable. So as long as we double that, we do the power reducing formula.
So you should get, as your final answer, 1/4 minus cos 2x over 2 plus 1 plus cos 4x all over 8. That's the final answer. You could probably simplify a bit more, maybe. Maybe pull out that 1/8 and add to 1/4, which would be 3/8 if you wanted to. You probably could do that as well. But I'd be good at this point. Unless you had to verify the identity and combine those fractions. Okay, so what this tells me is that this is going to be true. If I have sine square 4x, that's 2x. Sorry, 8x. That'd be 6x. That'd be x. Okay.
Let's see. Okay, this is gonna be double. This last part is a nice segue to the next identity, half angle identity.
You guys did not do this in this advanced class. He said you guys did everything but this. Actually, you guys don't think it did power reducing either. I assume that's new. So half angle identities. Let's take a look at this here. And if you took the square root of both sides, you get a square root on the other side, right? So let's derive it for sine squared x, or sine x over 2. So remember, sine squared x or okay. A square root. You gotta put plus or minus. Because you don't know. Positive or negative. Yeah, it depends on the situation I'm asking you. You'll see some problems in a moment. So see these other variations for cosine tangent right there. And by the way, it looks like what's happening here is a rationalization. That's how you get these two variations of tangent x and 2. If you multiply top and bottom by root 1 plus cos x, root 1 minus cos x, you get the other variations right there. Yeah, dude, go.
One over sine squared x.
We'll start to say it.
Wouldn't like, if you have one over sine squared x equals, wouldn't that be flipped? Because you flip the sine.
So did this flip?
Yeah.
Where?
Sure.
No, that's the numerator. No, let's look back at our formulas.
No, that was for tangent. No, that's the formula right here. It's right here.
Flip the sine squared x. So when you flip the other side.
Sine squared x. We flipped it.
One over. That's not a one over. That's not a one over. Oh, that's an arrow.
Wait. Oh, my handwriting sucks, dude.
What is that? Oh.
Sorry. My apologies. No, thank you. Thank you. I was so confused. All right, guys, let's keep going. You guys doing great. All right, so now here's the deal. Unfortunately, we can't use a sum or this one for that. So we're gonna use a half angle identity. What we're gonna do is we're gonna let theta equal pi over 4. Equals root plus or minus, by the way. That should be this. You can leave your answer like that. That's totally fine. I wouldn't mess with that. You know, I mean, how far can you go with radical simplification of it? Why is it positive, not negative? What quadrant is that in? That's when you have to make that determination. So Sean, to answer your question, that's how you can tell. Depends on the situation. You're the first quadrant, so you can go with that. Okay, why don't you guys try part B on your own? So what's gonna be your theta here? Good. Yes. I'll freeze the screen and we'll work it out. All right. You guys get that? We're okay. 1 minus. It's negative on the outside because you're in the second quadrant. Second quadrant, cosine's negative. Because 7 pi over 12 is slightly bigger than pi over 2. Okay, we're good? Yeah, go ahead.
Something like, I don't know if this will ever happen, but if you divide it by 2, like, one of them will be in the first quadrant, one of them will be in the second quadrant.
Wait, what do you mean?
Like, if you use the 7 pi over 12 as in quadrant two.
Right,
And so quadrant six, you can quadrant two.
right.
What if one is quadrant two and one is like one quadrant?
It doesn't matter, I mean, of course, you value this how it looks, right? It's just about, the answer has to be consistent with where it's located. That's all. But you're overthinking it, dude.
We're overthinking it. All right. Couple more problems, we'll wrap up these notes. Let me set these up for you guys. So 2 sine squared x. And that's good so far. That's a plus, my bad. Should be x, my bad. My apologies. What happens if you square a root and a plus minus? They just go away, right? We're cool with that so far? All right. I'll let you guys take it away from here. Okay, so you should convert the sine squared to 1 minus cos squared. Hint, hint. Yeah. You guys get that? Yeah. I don't think any of them are extraneous. I think all the work. I'm pretty sure all the work. If I check it out. So you see, we're stepping up our game a little bit, right? We're doing things a little more advanced. This is good. What you guys need? Yeah, because sine pi over 2 is 1. 2 minus 1 is 1. Cosine pi over 4 is root 2 over 2 squared. Becomes 2/4 times 2 is still 1/2. Sorry, wait one sec. No, squared becomes. Is that right? Wait. Hold on. If I put in pi over 2, cosine pi over 4 is root 2 over 2. You get. Wait, I'm confused. Hold on. Are one of these extraneous? Wait. Why am I tripping myself out here? If I plug in pi over 2, that's 1. Oh, no, yeah, that makes sense. Because you do 2 times half, right? That makes sense. You get 1. That's fine. You're good. Yeah, they're all good. Okay, let's move on to part B. Question about part A? We good? All right, we're doing great on time, by the way. All right, let's do part. Yeah, go ahead. Yeah. What is that pi?
Cosine x equals what?
And then it'll be negative.
Right.
Yeah, you can always verify in excuse me, in Desmos as well. Actually, let's do it really fast. Yeah, makes sense. All right, last one, guys. All right, why don't you guys try this on your own? We'll check in a moment. Try it on your own. Here we go.
I checked Desmos also. That's correct.
Oh, what stops you from just subtracting the percent of two X sin X, and then you just find the amount of sine is two X minus X.
Oh, wait, it's having what?
You just subtract one side.
Okay, but then what would you factor out?
And then, no, I don't factor anything else. Recognize that that's what I do that.
Oh.
So I just make it, sine two X minus. X.
Wait, what formula?
So this was-
Yeah, that's work.
Hold on. Wow, Kieran's on something here.
Yeah.
Yeah, that's clever.
I'll be big.
Yeah, that's what I meant to. I didn't mean to do it, but just kidding. No, yeah, this is what Kieran suggested. That's actually going to be the difference formula for sine. Where that's U of V. Yeah, that's really creative. Yeah, that works also. Yeah, 100%. So cool. Okay. Homework is going to be the rest of the whole problems in the set here. So where it says chapter 5, part 4 notes, there's 1, 2, 3, 4, 5, 6 problems there. Most guys have you guys go back and look at the ones I didn't assign, which would have been I think 5, 6, 7. So 5 is called product of sum trig identity. Number 6 and 7. Have you tried those as well? So we 5, 6, 7, part 3, all the part 4 problems. Now, in terms of the test, I'll just show you a test from last year because I know it's floating around, so I don't care. I'll show it to you. I'm gonna design it very similar to this test. I will give you guys these first three formulas, and I'll try to publish stuff today for Schoology and have stuff printed by tomorrow. These are only two I'll give you. So I'll ask you a question like this, right? Pretty straightforward. Not that hard. Remember these questions here, like that? Expect something like that. Gotta draw the angles and evaluate by exact values. Then we're gonna do 3 trig equations and 3 trig identities. So 8 problems total. And they will increase in level of difficulty. The first will be super easy. Next will be medium. Fifth one's gonna be more involved. Likewise with the identities. One will be kind of easy. A little more challenging. 8 was brutal. We could practice this on Tuesday. I should have yeah, I should have adjusted the points. So anyway.
You get that thing wrong, you get a B max.
Hold on. Hold on. You want to try it? Hold on. Let me make sure I have the answer key, guys. Hold on.
15 worth 15 points.
No, I'm not kidding. No, I don't have the answer key.
Wait, is it on the notes?
No, it's not. You should be that. You should look at that.
Yeah, I don't have the answer key for it, but anyway.
Not bad. I feel like I can do that.
Go try it.
That doesn't even
I
seem
do.
that- You just gotta scroll them up.
I know what it's gonna be. It's just gonna be the different formulas, and then you just have to like. I think I did a good
It's not possible.
I think you can also do power reducing.
Yeah,
Do
that's
that.
what I was gonna
Rush
say,
to do it.
that's another way.
Yeah,
This is the verify, right?
probably the right side, actually.
Do the weird story.
Probably the right side.
No, we do the left side.
Or left side. I don't know. It's up to you. I think they're both equally challenging.
Wait, just give me the other.
Wait, your denominators are gonna cancel out.
See here.